Welcome back to the Scotti-BYTE channel, and this is Scott. Today's subject is going to be virtual disks in Linux. So when we think of virtual disks, VDIs, VHDs, and vmdks come to mind in the case of Virtualbox or the QEMU disk images, which are used for QEMU virtual disks. Virtual disks are thought to only support virtual machines. But virtual disks can be used in Linux in many other ways. A virtual disk is a file inside of your file system that can be formatted, mounted, and accessed just like any physical disk on your system. Virtual disks in Linux use the loop device, which can make a pseudo or virtual disk that is only a file accessible as though it is fully fledged block-based storage. Virtual disks are containers that emulate various types of storage inside of a file. So what types of virtual disks are there? I'm going to cover the Unix file system, UFS-based virtual disks, which can be formatted to any familiar partition format such as ext3, ext4, exFAT, FAT32, NTFS, and many other formats. We can also mount an ISO image file as a read-only file system in Linux, providing access just as though it were a physical CD or a DVD. We can create a ZFS pool inside of a file, and recall from my previous videos that ZFS combines the features of a file system and the features of a volume manager. Unlike Windows, where we refer to drives by letters, Linux has only one file system called root and is denoted by the /, and it also has an almost unlimited number of physical disks that could be used to extend that root file system. Physical disks and virtual disks are mounted in Linux by creating a parent folder and then mounting the disk in the folder, which is referred to as a mount point. From the end user perspective, the Linux file system appears to be one tree structure starting at the root, and users do not perceive mount points any differently from ordinary folders. We are going to learn how to create, mount, and access UFS, ISO, and ZFS virtual disks in the Linux operating system. I want to start out today by pointing out that I'm on a LXD virtual machine. And when it comes to Linux virtual disks, they're only going to be supported on virtual machines, LXD virtual machines, and bare metal machines. And the reason for that is because those three example types of machines have their own dedicated kernel, whereas LXD and Docker machines share their kernel with the host. And therefore, the loop device or ZFS storage pools can only be accessed from those physical machines and virtual machines because there's a privilege issue. So looking at my virtual disk here by doing a df to list all of the storage, you can see that SDA1, which is the first partition on the virtual machine, is my EFI boot partition, whereas the second partition on the disk is the data partition in /dev/SDA2, and it's approximately 100 gigabytes, and that's going to be the user area for which we perform our operations. So the first step is we're going to use the Linux dd command. So the dd command is simply a copy command, and you copy from an input file to an output file. In this particular case, we're copying zeros over to an output file in the media directory to a disk called, or a file actually called vdisk.img, which will ultimately be our virtual disk. And the block size of that disk is 1 megabyte, and there's 1,024 of those 1 megabyte blocks. So by a best practice, if you have media such as a virtual disk, putting it in the media directory is always a good idea so you can track where it is on your system. So I hit enter. I use the sudo command because the media directory is owned by the system. And there you can see it wrote out the 1024 blocks. So the second step is we're going to use the make file systems command, which is essentially a format command. And this format command will make a file system with the ext4 format, -t means type, ext4 format in /media/vdisk.image, which is the file we just created. And there you go. We have just formatted that file as a disk. The next step is we're going to create a folder in the mount directory with the sudo make dir /mnt/vdisk. So mnt directory is normally, by best practice, the folder where we try to put all of the mount points. Of course, you can create mount points in any folder, but I'm just doing that because that's a best practice. And then finally, the next step I'm going to take is to actually mount our disk. And that's done with a sudo mount, and we're doing an automatic mount, and we're using the loop device. And the loop device is the device that I mentioned earlier that allows us to mount virtual disks. And we're mounting the virtual disk in /media/vdisk.image, and there's a mnt/vdisk, which is the mount point. And now the disk is mounted. So I could cd over to /mnt/vdisk, and you'd be able to see that there are no files in it. If I could type in ls correctly, there's just a lost and found file in there. And for right now, if I try to do something like a make dir test, I'm going to get a privilege violation because I do not own the mount point, therefore I don't own the disk. If several users were going to share this disk, then I could just create them folders owned by their particular user account. But in this particular case, I'm just going to change the mount point to be owned by the Scott account, which is the account I'm logged into, with a sudo chown Scott:/Scott /mnt/vdisk. Now that I've done that, I should be able to do a make dir of test, and it should work. And it does. So I do an ls, there's the file. I can say touch test file. That creates a file. I do an ls, there we are there. If I want my system to mount this disk all the time and not just interactively, where I'd have to do the sudo mount command up here every time, what I can do is I can go edit the fstab file by doing a sudo nano /etc/fstab, which is the file systems table, and it's the place that we mount files. And you can see here on my virtual machine that I don't have nano, so I'm going to do a sudo apt install nano, and then we'll try again. Okay, so in this file, we simply put an entry like this, /media/vdisk.image, which is the image file that we created, the file that actually contains the file structure, mounted into /mnt/vdisk. It's an ext4, and I have defaults and then 00 at the end. So save that out, and we'll do a sudo reboot. And I'm going to sign on to my Scott account. And then I'm going to bring up the Nautilus File Manager. And here you can see that MNT has been automatically mounted. To make the vdisk disk more accessible, we're at Computer, Mount vdisk. We can go under the three-dot menu here, and we can say Add to Bookmarks. And while we're doing that, we really don't care about the MNT directory, so we can right-click in it and say Remove. And so now we have a folder for vdisk and a folder for media. If we go into media, there we can see the vdisk.img. If we go into vdisk, we have our files that are mounted to the file system in our sudo or virtual disk. Now, if we go back to the media directory, you'll notice that I have, in addition to our disk image that we created, I also have two ISO files, and one of them is for the Ubuntu 2204 desktop image, and the other is for the Ubuntu 2204 live server image. In order to mount that ISO image, first we have to create a mount point just like we did before with the virtual disk, and I'm going to do a sudo makedir /Ubuntu-DVD. It's going to ask me for my sudo password, and there we've created the mount point folder. The next step that I have to do is simply the mount command, and that will look like this. Sudo mount -o, we're using the loop device again, /media /Ubuntu 2204 desktop -amd64.iso, which is this file that you see right here in the Nautilus File Manager, and we're mounting it through the mount point that we just created in MNT /Ubuntu-DVD. And now you can see that it says it's mounted, but there's a warning that the source is write protected and it's mounted read-only, which is what you would expect with a CD or a DVD. So if we go back to media, we can see here those disks. If we go over to the mount directory with other locations, and we look at computer, and we look at /mount, and we look at Ubuntu DVD, we can now add Ubuntu DVD with an add to bookmarks, and you can see that we have an Ubuntu DVD here. If we click on it, there you go. That's the root directory. Going back to our virtual disk, here's our virtual disk we created, and here's the read-only DVD of the Ubuntu scene right here. To unmount the ISO image, I simply do a sudo umount /MNT /Ubuntu-DVD, and if you watch carefully in the background, you will see the DVD image go away. So there you go. We're back up at the MNT directory where you can see the mount point, but there's nothing in the mount point. The folder is empty because it's not currently mounted. Of course, if we go to our vdisk, it is still mounted at this point in time. So on the channel in the past, you notice that part of the setup process that I use to create a LXD environment is a LXD init. And during the LXD init, I always configure my storage pool as a ZFS storage pool. And the reason for that is because ZFS performs a copy on write when data is to be changed on the disk, unlike typical file systems which just overwrite data. And as I mentioned in the past, this means that when new information is written to a ZFS file pool, it's written to different locations on the disk, and once the write is completed, the metadata is updated to point to the new data. The result is that a ZFS storage pool provides a really high degree of reliability. So in order to use ZFS, we're going to have to install the ZFS utils for Linux. And we do that with a sudo apt install space ZFS utils -Linux if it's not already installed. Now that the ZFS tools are installed, the next step is to be sure that ZFS is up and running, and we can do that with a sudo mod probe space ZFS. And if you don't get an error back, that means that ZFS is installed in the kernel of your operating system, and that should be in the case of any of the later operating systems. Here I'm running Ubuntu 22.04 in my VM. And like before, when we created a space for the virtual disk, here we're going to do that a little bit differently. I'm going to do a sudo truncate the size of 1 GB /media, and I'm going to call this vzfspool.image. So we've created the file in which our ZFS pool is going to be in, and it is a 1 GB area. And finally, we do a sudo zpool create my pool, and with /media /vzfspool.img. Now, since ZFS is both a file manager and a storage manager, that operation not only created the pool or the structure inside of the vzfs pool.image file, but it formatted it, and not only did it format it, but it mounted it. And if we do a df command, you can see that I have my pool here. And by default, it mounts it at the root level of your system. And I'm going to dedicate this ZFS virtual pool specifically to the Scott account. So I'm doing a sudo chown to the Scott account of /mypool, which is the mount point. Now that that's been completed, if I cd over to /mypool, I should be able to say make dir test z. And I should be able to say touch testing z. And then I can go into my Nautilus file manager, and if I go look at media, you can see there's the ZFS pool. And if I go look at other mount points, go to computer, and I go to my pool, then I can add a shortcut for my pool. And now I can go to my media folder. There's where all my media is. I can go to my virtual disk we created earlier, and there it is. The DVD is not currently mounted, so that folder's empty. And I can go to my pool, which shows the files that I just created with the ZFS pool. So another thing about ZFS pools is I can reboot the system, and the ZFS pool is automatically mounted without having to put anything in the etc fs tab file. And as an example, let's go ahead and do that. So I do a restart, click on restart, my virtual machine exits, I bring up my virtual machine console, I go to full screen, it logs into the default Ubuntu console account as soon as it boots up, and I go ahead and log off of this account. and then I log into the Scott account, type my password, I'm in. So recall that with the etc tab file, we had mounted vdisk so that it would work on every boot. But we didn't do anything with the ZFS pool in particular, but there it is because ZFS pools mount when the system boots. So other interesting commands to know about ZFS is you can do a sudo zpool list, type in our sudo password, and you can see that we have one pool and it's a size of 960 megabytes, which is close to a gigabyte with overhead. And this is currently just a file. ZFS pools can grow very large, but this is a virtual ZFS pool. And as I mentioned on the outset, this is very similar to what LXD creates when it creates your default pool with the ZFS format. We also have a command called sudo ZFS get all, and this gives you information about ZFS and how everything's set up. And the thing that I find of interest here is it says that the mount point for my pool is here in the /my pool at the top level of the disk. Now, I'm going to go ahead and change that, because what I'm going to do is I'm going to create a folder over in the MNT directory where we have our mount folder for our ext4 virtual disk mounted with the loop device, and I'm going to create a similar folder called vzfs pool over there. And then I'm going to change the mount point to point over to that particular folder, and I'm going to do that with the sudo zfs set mount point equals to /mnt /vzfs pool, and I'm just going to call it my pool, or actually my pool is the name of the ZFS set, and that's why we've got that there. So at this point in time, I'm not sure if we can still reference the folder down in my pool, and the answer is we can't, because it's been changed over real time. So we probably want to remove this my pool down here, and we instead want to go into media. Well, not into media, we want to go into MNT, so we go to other locations, we go to computer, and we go to MNT, and then we go into VSF pool, VZFS pool, that's a tongue twister, and then we say add to bookmarks. And by the way, you can move these bookmarks around, so if I want to move this one first, I can do that. And so now if I exit my terminal, exit my file manager, and just bring up a fresh Nautilus manager, and I go directly over to VZFS pool, it's going to be in this location. So again, in terms of review, if I go over into the /mnt folder and I do an ls, you can now see that there's an Ubuntu-DVD mount point, which is a folder. There is a vdisk mount point, which is a folder, and there is a vzfs pool mount point, which is a folder. So if we do a df command, you can see that my pool is mounted, but now it's mounted through /mnt /vzfs pool, and you can also see that there is a mount for vdisk through /mnt /vdisk. So even though we don't normally dismount ZFS pools, we don't worry about mounting and dismounting them, because there are ZFS commands that can be used to destroy them, there is a command called sudo umount mypool. And if we do that, provide our password, and again, we do a df, you can see that my pool is no longer in the list, so of course it's no longer accessible. In order to remount that pool, we just turn around and do a sudo zfs mount my pool, and it's mounted again. If we do a df command, you can see that once again it is back. And if we do the command sudo zpool destroy my pool, this actually dismounts it and destroys it, and the end effect is that we no longer have a pool. And if we do a sudo zpool list, you'll notice that no pools are available. And as a warning, if you do the destroy command, all of your data will be gone. And if we do an ls, we can still see that in the mount point it exists. If we do a cd over to /media and do an ls, you can see that there is still a vzfs pool.img, but that pool is no longer valid, because if we turn back and try to reconnect it again with a zpool create command with the same name and using the same file, you'll see it creates it. If we do a df, it's mounted, but once again it's mounted up at the root level because that's what it does by default. And if you like, you can always set the mount point back again as a reminder with the set mount point command. And if we do a df, now you can see it's back where we had it. However, if we go into /mnt/vzfs pool, despite the fact that that file wasn't deleted, the action of recreating the pool clears all the data, and as you can see, there's no data inside of the device. So a warning, the destroy command really is a destroy command, and when you recreate the pool, it will clean out everything. So in summary, we learned that the loop device can make a read-write file system in a single file or a read-only in an ISO image available to the end user as a virtual disk. We saw how a ZFS pool can be created inside of a file and accessed just like any other file system. And for some applications like LXD containers, ZFS is a superior solution because it performs a copy on write, whereby new information is written to a different location on the disk, and when the write completes, the metadata is updated to point to the new data, thereby making the file system far less susceptible to corruption. Virtual disks can provide additional utility to your applications. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell.